All right, let's do a quick recap of a bit of quadratics. All right, question one. I want you to solve for x and y given 3x squared minus 9 is equal to y, and equation number two, y equals negative 3x plus 5. All right, so when you're solving this question, let's go through it. The first thing we can do, we can see that both equations equal y. The first equation, we have y equals to 3x squared minus 9. And the second one, y is equal to negative 3x plus 5. So if we want to find x and y that will fulfill both equations, the exact same x value, the exact same y value that would fulfill both equations, we can probably remove the y and just equate them. And once we equate them and remove the y's, we can then have the opportunity to solve for x first. In which case we'll be dealing with a quadratic that might end up, or that will end up equaling to 0. All right, so let's do that. The first thing we're going to do is take equation, let's call this equation number 1, equation number 2, and we equate them. So we take 1 and we make it equal to 2. 3x squared minus 9 becomes equal to negative 3x plus 5. Bring everything over to the left-hand side, carefully changing sides and changing signs. So this ends up as 3x squared plus 3x minus 9 minus 5 equals 0. Minus 9 and minus 5 becomes minus 14. Now you have this trinomial, or quadratic, which maybe it can factorize. Maybe. I put 3x over here, x over here, and let's say I put 2 and 7 over here. This is going to be 14, but this is going to be 6 and 7, probably not. Doesn't seem so easily factorizable. If you're finding factorization of quadratics difficult, what you can do is use the quadratic formula. So we take a equals to 3, b equals to 3, and c equals to negative 14. And so therefore x will equal minus b plus minus the square root of b squared minus 4ac over 2a. And we then substitute carefully. So minus 3 plus minus square root of 3 squared minus 4 times 3 times negative 14, all divided by 2 times 3. Grabbing your calculator, press the fraction button, and then carefully type each of that in. So fraction button, negative 3. Start with plus, let's say. Press the square root. 3 squared is 9. I'm just going to put 9 in my calculator. And 4 times 3 times 14. I can put that in together as well. It'll become plus, because two negatives will multiply. So these two negatives will become positive. And we'll end up with 9 plus 4 times 3 times 14. All divided by 2 times 3, which is 6. So the first solution for x comes to 1.72 to 3 significant figures. And the second solution, keeping that in your fraction, change plus into minus. So you don't have to retype that entire expression in your calculator again, getting you to negative 2.72 as two possible solutions for x. Now that you found x, all you have to do is find y, right? So what do we have? We've got x equals to 1.72 and x equals to negative 2.72. And let's say I choose this equation because it's easier than using the squared, I could use either equation to get y. Y equals negative 3x plus 5. And so we substitute x in there, getting each y value. So y will equal negative 3 times 1.72 plus 5. And y will equal negative 3 times negative 2.72 plus 5. All right, grab a calculator again. Negative 3 bracket 1.72 close bracket plus 5 comes to negative 0.16 for y. And on this side, negative 3 multiplied by negative 2.72 plus 5 will come to 13.16. And so 13.16, and that would be my y values, and these are my corresponding x values. We can write these as coordinates, 1.72 and negative 0.16 and negative 2.72. And my y value is 13.16. Let's see if we can draw a sketch of this graph, more or less, after this. So we got 3x squared. Let's just double check that equation. So the first equation we have is 3x squared minus 9 equals y. So y equals 3x squared minus 9. How do you sketch this function? Let's get the Cartesian plane, the y and the x-axis over here. And let's start with the number that does not have x. That number would be negative 9. Let's take negative 9 and put negative 9 somewhere over here, let's say. Okay. I also know that this value, which is my a value, is positive. So I know the graph is going to be smiling like that. All right. If there's any other information that I have, I also have, let's write this equation, negative 3x plus 5. So y equals negative 3x plus 5. And my y-intercept is 5. Okay. It'll be about here somewhere. This is a sketch. This is not drawn to scale. And from here, we've got a line that is also sloping towards the left because it's negative. So we will end up with a gradient of negative 3. So negative 3 over 1, changing y by changing x makes it a little steeper than flatter. So more or less something like that would be the straight line equation. And the intersection points could be a guideline. I mean, we've got 1.72. So go that to the right, go that down. 1.72 and negative 0 point could be the first coordinate over there. Let's say I call this A. Then I would put A over there. And B, negative 2.72 and 13.16. So negative 2.72 would be, let's say, over here. And 13.16 would be maybe over here. And let's call this B. That would be going left and up. And those are the 2 points of intersection. They're going to lie on both the curves. All right, so let's move B around. I'm just going to move B around and place B on the line. All right, so probably going to change the steepness of the line, or I can remove B and put it on the line. This is just a sketch, remember? So it's an idea of, it's not going to be much accuracy. If you do a graph paper, you can. So let's say B would be over there somewhere. All right, and A has to lie on it as well. So let's move A over here. I'm going to call this A, and I'm going to call this B. And those are the 2 points where the parabola has to go through as well, the quadratic, the 3x squared minus 9. So the next thing is to sketch that, which is a curve, which is a smiley face curve that's going to go through 9. And at the moment, I can see that it will turn most likely before it gets to the -9, or it will turn at that point, most likely at that point. And how do we know that? Because there is no b value in my equation. Right. So this is y is equal to 3x squared minus 9. And this is y is equal to -3x plus 5. And those are my two coordinates or points of intersection. So from this here, if you want to find the x value of the turning point at any point in time, you can do that by taking minus b over 2a. But because my b value is equal to 0, the turning point x value becomes 0, no matter what the y value is. So it's going to turn at that point. And if we make x equal to 0, y will equal -9. So that's going to be my turning point. It will be symmetrical over the y-axis.